All right, looks like this is going to work. Okay, so we're going to try destroying this factory. This is a simulation of an Israeli attack on an Iranian steel mill. And so we need to use this thing called OpenPLC Editor that didn't work when we tried it earlier today, but this time it's working, probably because I updated it. So you launch OpenPLC Editor on your Windows machine and do File, check for updates, and put on the update. And now we're going to create a project, which we did in an empty folder. And I did it all. I'm not going to do it again. I'm just going to talk about it because these instructions are working fine. You now create a new folder named main with the language FBD for functional block diagram. And then you use the green plus sign here to add 2 lines, and you give them these exact names: I_sensor Boolean %ix 100.0, as you see here, and the other one is %qx 100.0. Those are the names that it will find in the simulated hardware we're going to control. Then you drag those boxes down here and double click this one to change its type to output. So the connector will move to the other side, and then you can drag and drop a connector from one to the other. So now you've created a little circuit here, and now you can just compile this by clicking the yellow down arrow here. That will compile it, as you see here, and then save it with this name ot121.st in that folder. Now, let me get my instructions visible on another screen here. So we created a compiled program. Now we're going to have to upload it to the factory. So we opened the OpenPLC dashboard. We're running PLC on Linux, and here's the dashboard. So it's OpenPLC and OpenPLC to log in. All right. Okay, now we have to upload the program. So we hit Programs here, and then Browse, and find our program, which is either download or documents. I guess it's documents. Well, now I guess I don't know where it is. Okay, let me go try to figure out where I saved it. Maybe, let's see. Up here, I saved it. It had me make a new folder. Yeah. And I guess I don't know where it created the folder. All right, let's see if I can figure it out. It's not in downloads. Maybe it's in my home folder. There it is. It's in my home folder. Okay. All right. So I want to go to here, browse. Okay, let's try. Okay, the only way I know how to get anywhere is the old-fashioned way from MS-DOS. C, users, student. Okay. And in here, there's the OA, OT121, and there's the compiled program, OT121.st. Okay, so I open it there and then upload it. All right, and then upload program. Name cannot be blank. Well, I guess I have to assign it a name now. Okay, OT121. All right, now I should be able to upload it. Here we go. All right, there it is. Apparently it has to compile it again. And now I go to dashboard. Okay. Now, let's go back to factory IO, which is here. And we'll choose a scene at the top left. All right. I'm in trouble again. Remember, there's minimize. Okay. There's some way to get back. There's factory IO. Okay. Whatever that other window was. All right. Here we are. So now one from A to B. I've already got one from A to B. The scene loads. Let's try home. There we are. Home, scenes. Okay. One from A to B. Now we're on track. I will discard my unsaved changes. Okay. Because that was from a previous project where we used a different thing. Now we're going to use Modbus, so it's actually remotely controlled from the PLC. So it's File, Drivers, then Modbus TCP/IP server. Okay. Now we hit Configuration, and there's a host IP at the top. We're going to need this later. 192.168, I'm going to make a note of it somewhere. 192.168.0.137. All right. That's the address of our factory. Okay. Now we scroll to the bottom, and there's I/O ports here. By default, there are 2 digital inputs and 1 digital output. And that'll be fine for what we're doing here. You only need 1 input and 1 output. So at the top left, we go back. And now at the bottom right, we click the eye icon. So this becomes transparent and we can see the scene behind it. Now at the top center, the IP address is shown here with the port number, 192.168.0.137. That is the address of our port. Okay, along with the slave ID, which is 1 by default. Now we're going to connect OpenPLC to the factory. So that's here. All right, so we're going to click Slave Devices. And there's an existing slave device we made before in a previous project. We want to get rid of it. So we click the slave device's name and then delete. Okay, now there's no more slave devices, an empty list. That's what we want. Now we add a new device. And here, the device name is Factory IO. And it is a generic Modbus TCP device. The slave ID is 1. The IP address of our factory, we noted earlier, is 192.168.0.137. And the port is 502. Okay, and discrete inputs. It is, all the starting addresses are 0, size 2 for this one, 0, size 1 for that one, and all the rest is zeros. There. All right, when all that is done, we save device. And there it is. Now we start the PLC. And the log starts showing it is connected to the factory. It's running. Okay. So now we're in business. On the left, we can click Monitoring. And it shows the input and output connected correctly. All right. They show green lights. So now we can run the scene in Factory IO. We go back. And now run. And there it goes again, running down the conveyor belt and correctly stopping at the end because it's being remote controlled by Modbus from the Linux machine, which is what you want. Okay, so that's the start of it. Now, the fun part is to attack it with Metasploit. So you install Metasploit on your Debian machine and launch it. So let me make my remote desktop smaller. Okay. All right. That's the Windows machine. Here's my Linux machine. Now, this is the PLC controller running, and here's Metasploit running, which I've got going. So now, again, I'm going to search for Modbus attacks. And there's a bunch of them. And the one I want is to find unit ID, which we used before. And that's going to be number 12. So I use 12. And show options. The only required thing is the R hosts. So I set R hosts to, I assume, the IP address of our factory, yep, which is that number we made note of before, 192.168.0.137. That's correct. Okay, and we set unit to go to unit 2 to 10 and run. This is what we've done before. This will scan to try to find out what's available. And you see station ID 1 is correct, and all the others are not in use. So it found that. So now we're going to read data from the slave. I'll wait for this scan to finish. Okay. So now I'm going to use another one here, which will read data from the slave. And I need a data address and some other things here. I set the data address to 0, set the number to 5, and again, set the R hosts to the address of my factory, 192.168.0.137, and set unit number. You may remember our slave is number 1 now. That was the default of factory IO. So this will now read data from it. And as you can see, it gets 5 zeros, which is what we had. We haven't set anything more. So now we're going to start the conveyor, info, and you'll see this module can read, but it can also write. The same module can do it. So what we're going to do is set the action to write coil, set data to 1, okay, and run the exploit. And I'm going to shove this to the side so we can see the factory back there. Okay. There. So if I run this exploit, it's going to send a signal to the factory to run and see it started, but then it stopped right away. Now that's because there's a running control program that stops it when it hits that sensor at the end. So now you could stop it with a variety of attacks like a denial of service attack over the network. To simulate that in our environment, we're just going to hit this stop button here. If you have stopped the existing controller from controlling it again, then you can attack it from Linux here. If I get to the right window there, exploit. Let me get this to the front again so we can see it. Now I do exploit. And the conveyor should turn on and dump the box at the end, but it looks like it didn't work here, which is annoying. That was the punchline. But I'm going to stop the recording and debug it and start another video if I get it working. Stop the recording.